Alright folks, last class we ended up by just working through a frequency table, but we talked a lot about how to organize and display different data types. So last thing we did was work with this reaction time frequency distribution, and it ended up being a continuous quantitative distribution because we said we didn't want to separate these into individual values. So we set up our classes, class size of 100. Remember, the left sides included, the right sides not, and used our frequency function in Excel to help us fill that frequency table out. What we're going to talk about just is to go over once again the difference between a bar graph and a histogram and hit on some key points. We've talked a little bit about the categorical data versus continuous or quantitative data. Because technically you can use a bar graph for quantitative data if it's discrete and there's not a lot of values that would appear. Otherwise it's better to group it into a histogram. So distinct categories are required for a bar graph. They have gaps between them, although you may have seen ones without. That's not really a requirement. That's the emphasis. It's what really is going on this x-axis. That's the emphasis. Okay, so they have to be discrete groups, be in those specific categories, and it wouldn't matter what order these are. Okay, we spent a lot of time talking about the levels of measurement last class. These ones don't have to be in a specific order. Whereas when we're talking about a continuum of numbers, it makes sense to put them in numerical order, and in fact it's required. When we talk about that class width, not only did we pick it as 100, it's in fact required that all of them have to be equal to do a histogram here. So when we're looking at this, it doesn't have to start at 0. Ours didn't last time, but this one's going 0 to 10, 10 to 20. And generally, we're not going to label it this way. You would see the labels here, 0, then 10, then 20, then 30, then 40, then 50. And you would have to understand that the left side's included and the right side is not. Now, with us using Excel to create our displays, we're not going to be able to do that as nicely as if we were creating it by hand or using some other applet. Okay, but big difference, categorical, that's going to be our qualitative data, and this is going to be numerical, it's going to be our quantitative data, specifically grouped numerical values. So we're going to go back really quickly through our examples that we covered last class and just classify them as which one would be most appropriate. And we did this a little bit when we were talking, but I just want to go through it one more time. So we already talked about this one, and it showed you, in fact, the bar graph version. Wrist circumference, since it is a quantitative variable, that's something that could be put in a histogram. Same thing with height. Handedness would have to be a bar graph. Number of languages spoken, because we only go up to 4, this one could be a bar graph. 1, 2, 3, 4. It's discrete, remember. It wouldn't really make a lot of sense to do this in terms of a histogram, even though it is quantitative. And then gender would be a bar graph, and province, would be a bar graph. Okay, the M&M example, those colors are categories, so that's going to be a bar graph, and they showed you those bars specifically when we were comparing the frequency to the relative frequency distribution. Similarly, our hair color example, that would be a bar graph as well. So what we're going to do for the rest of class is talk about these visual displays. So when we look at the displays, we can describe the pattern of the numbers in a few different basic ways. The first one, if your data looks the same on both sides, and it wouldn't have to be the highest in the middle, although we do see this shape pretty often, this bell curve as you see it, that's going to be roughly symmetric, and it doesn't have to be exact here. Now, I've given you these visuals in terms of discrete dot plots, but this would apply for histograms as well. This can even go as far as dealing with skew in box plots, which we'll cover next time, or stem and leaf plots. It all applies to different displays of our data. Okay, so roughly symmetric. If you fold it over, you're going to see about the same left and right. Okay, when we have skewed to the right, that means most of the data is actually on the left, but there's these higher numbers that are skewing it or pulling it to the right. So the direction of the skew is where you see kind of this tail off, or the tail of the data. Again, this is discrete, but if it's continuous, a lot of times instead of being written as skewed to the right or right skewed, they'll say positively skewed for that continuous data. So we'll use that language when we're referring to our histograms. Similarly, if we have most of our data on the right-hand side, but then there's these lower values that are skewing it to the left, or we see the tail on that left side, that would be skewed to the left or negatively skewed. Okay, so we're kind of going to jump around a little bit here. I told you that the book 2.1 and 2.3 really go hand in hand together. So we're going to take a pause while we're talking about displays to just talk about good and bad ways to use data and graphs. So this is our 2.2 using and understanding graphs. We're going to assess them for information and quality. So I have 1, 2, 3 examples of graphs here that something is obviously wrong with them. What I'd like you to do is talk to the people in your table and discuss what issues you find with each of the images. And then when you've taken probably about 5 minutes total for the 3 graphs, more if you like, then I would like you to come back to the video. Excuse me. Come back to the video and I'll go over some of the thoughts. Okay, so pause the video and take care of that now for me, please. Alright, so hopefully you saw on this first example here that we have 2 entirely different scales. So it's really hard to see like the relative change, kind of like we talked about relative change in terms of our percent increase and decrease being an issue with misconceptions before. So this was intended to make it look like the cancer screenings and prevention services were taking a dive bomb, but you'll see this number is still relatively larger than this one. It's really better for us to compare these with a similar scale and talk about that overall change. So if you scroll over to the right, I have an adjusted graph. So here, we've got what's happened with the screenings, and they have gone down a significant amount. If you look at that, it was from 2 million to under 1 million. Okay, and then with our number of abortions that we saw, that went up, but really not by what looks like or appears to be a significant amount. Those percent changes would be something that could be useful to talk about information, but remember we do have things that we talked about to be wary of, and we want to think behind what the data shows and talk about what's causing it. Correlation doesn't mean causation. We emphasized that a lot a couple class periods ago. So we don't know any more information than what's presented here. It's really important that when we're comparing things, our scale, when we are graphing things, it's got to start at 0. Okay, if we don't have a scale, or if our scale is broken, it doesn't start at 0, then the changes are going to look more extreme than they probably are. And sometimes that's useful, or sometimes it's intentionally used to misconstrue the data. Okay, similarly, on the next one, okay, you'll notice this scale was not at 0. So this, we've got this big, looks like sharp decline, but if you look at the numbers and adjust it over here, we only have this very, very, very small piece of information here, and here's our scale starting at 0. So they only gave us a little bit of the information for a short period of time and our scale. So there's really 2 issues going on here. So things to keep in mind. Another thing that is important to talk about, just throwing this out there because gas prices are always a conversation when it comes to it seems like politics. A lot of times demand is a big play here. When you think about gas prices, when they're higher or going up, that's going to be the warmer months, and then people aren't traveling as much. during the colder months, and so gas prices are traditionally lower. So that's a third factor or a third variable that doesn't necessarily mean causation of the other one that they're trying to pick on. Okay. And then this last one is just funny because we've got this monster woman from Latvia and then this really tiny baby woman from India. This is called a pictograph, and pictographs are very bad, y'all. We don't want to use them because a lot of time visually we're gonna view as humans area to relate size rather than vertical height, and that is what they were intending to do here. So again, we have our y-axis scale not starting at 0, so that's not proportionally relative. And additionally, when we're stretching this out, we're viewing a horizontal change as well as a vertical change. So here is the adjusted one. Not a significant difference between the few of the selected countries that they were looking at. All right, just to be able to interpret some different types of charts other than the ones we've been working with so far, I wanted to show you some stacked bar charts. This allows us to compare different categories within a specific organization. So here we're looking at the Winter Olympics medal count from 2014, and it's broken up to these different countries who were participating and their proportion of total medals there. So we're just going to answer some questions here, and I'll have you again just pause the video and see if you can, based on this graph, read and answer the questions working together with your table group. Okay, I'll give you a couple minutes for that. Pause and come back. Alright, so for this one, what country brought home the most medals overall? We're looking at that for Russia. It's the total height, or the highest bar overall. And then who scored more silver medals, Norway or Canada? We're just looking at literally the silver chunk for those two. So Norway's over here, relatively small silver chunk, and then Canada right next to it is significantly larger. So Canada will be the winner there. Okay. For questions like these, I won't ask you specifics unless there's a detailed scale of like what the total would be. So here you could estimate the number of silver medals for a country based on this scale, but you wouldn't be certain. This one's pretty good because, or you'd have a pretty good idea because when we're talking about medal count, that's discrete, has to hit on that whole number value. But with other scales, if it's not obvious, a data label is required, or you have to have access to the raw data to be able to answer those questions. Okay. Pie charts we talked about were for categorical data, but specifically when we're talking about a proportional part to whole. So we've got total spending here. And this one we want to know how much money did the government spend on nation defense according to the pie chart, and then how much money did the government spend on Social Security according to the pie chart. So this one we're going to have to do a little bit more work on. So I told you last class that pie charts usually use percents as their proportions rather than decimals. So that we can see happening here. It looks like they rounded to a whole number, even though that is not necessarily an exact value. Similarly, we have the total spending rounded to the nearest hundredth of $1 trillion, so lots there. And we're going to use that to work backwards. So just like if I wanted to know 50% of $10, we take half of that, or the proportion as a decimal. We're going to do the same thing here. We're going to take these percentages and change them to our proportions as decimals to multiply them by our total number here to work backwards for each of these questions. So the first one we're looking on nation defense, and national defense here was that gray section of 16%. So over to the side, remember we want to use the equal sign first for all calculations in Excel, and we're changing that to 0.16. The times button is the asterisk at the top of the 8 button. Okay, and then we're going to multiply it by our 3.36 to get our value here of $0.54 trillion. I'm going to round to the same thing their table did. So about and I'll put my dollar sign first, 0.54 trillion. Okay? We're not rounding to two places because it's money. We're rounding to two places because they did, because those decimals don't really mean a lot in terms of cents when we're talking about trillions of dollars. Similar, we're going to do Social Security. That's the blue chunk, so 38% here. So again, equals first, changing that to 0.38 times that 3.36. And this one is about 1.28 trillion. Now, there is a rounding function in Excel, but to me it's easier just to look at it and round normally. If you struggle, just remember you can use these features to add or take away decimals to round it for you. It's just showing you the rounded value. It's not changing the number. That's my favorite way to round, so I won't worry about that other feature. Okay. Now we're going to get back to what we were doing before, working with continuous quantitative data, and we're going to create some histograms. So I went ahead and made a little chart on how to make a histogram when you're doing it by hand, because if you've made one of these, which you may not have, honestly, it would have been in Algebra 1. So it's been a long time since creating one by hand, so we're just going to talk about how it works. So first of all, we're going to choose the intervals that cover the data. And that usually means knowing what the minimum and the maximum are and picking a good number to count by. Then, with that information, we're going to make a table of frequency or relative frequency, depending on what we're working with. And then we will draw our picture with our labels, and then add our scale, and mark our different intervals to represent those frequencies that we got from our table. Okay? So looking at this example, this is covering different states and their percent of foreign-born residents. Okay, so they've got this organized in a table here. And it looks like if we go over here, it's 0 to almost 5, 5 to 10, 10 to 15. So they use a class width of 5. Now, this one has a histogram that's really nicely built out here, and it's got the labels where you would traditionally see them. So I told you the picture above wasn't great, but it's how Excel will generally label them, is we're going to accurately, if we're making this by hand or using another app, put 0, the low bound on the left, and the high bound on the right, labeling the lines, whereas the categorical bar graph will label the gap. Okay, so this says all the numbers between 0 and 5 go here, and then 5 to 10 go here, 10 to 15 go here, and so on. So that gets us exhaustive because we covered all the numbers that show up in this table, and we're mutually exclusive because they said the first one will go to almost 5, and 5 itself will be included in the next one. So the left side's included, the right side is not, moving all the way through there. So they did the count here, got all 50 states, and there's our histogram. So just to bring back what we were referring to about shape up above, I want you to tell the person next to you how you would describe the shape of this. Your options are symmetric, positively skewed, or negatively skewed. Discuss. Okay. Hopefully you said that there was a tail on the right-hand side, so that is positively skewed, skewed to the right. Again, the text is going to use positively skewed to talk about continuous data on a histogram, whereas skewed to the right is more for discrete data. Okay, so now what we're going to do is set up that exact same thing, and we're going to do it instead. Okay, so basically we're going to recreate that to make sure we know how to do it with Excel. So I gave you a different chart of how this works with Excel. The first thing we're going to do is choose what our class width is. The first time we did this up above to make a frequency chart, I just said, have you pick, okay? In general, you can pick if it's obvious. Here's a good rule of thumb. You can find the range of the data and divide it by the square root of n, and that will give you a rough number to count by. Now, we're not going to count by a weird number like 4.34. Okay, we're going to round it to a nearest whole number, the nearest 5, 10, or like we did last time, the nearest 100. It depends on what our data looks like. So what we're going to do is start with that. I retyped this data so you wouldn't have to. Yay, you. Okay, and we're going to find the range, which means we need the minimum and the maximum. So we'll set those up. Hopefully you remember from last time, in Excel, a lot of the functions you could possibly need are just called their own name. So equals min to find the minimum here. And then we'll select the data range and hit enter for that. So our lowest number is 1.2. Remember, that's representing the percent of foreign-born residents. And then we're going to do equal max for the maximum. Same way. That will give us a good idea of how far apart our numbers need to be so we know what to count by. And then the range just subtracts those numbers. So equals, take maximum minus minimum. There is not a built-in range function in Excel, or I would have you use that. I'm all about shortcuts. There is not one for range. Okay. Then, using our formula, okay, 26 is something that you can see why they counted by 5. They just went 0, 5, 10, 15, and so on to get to 30. Okay, but let's look what this formula that is up here does for us. So we take that range and divide it by the square root of n. So our n was just the number of items here. Now, I know it's 50, but I wanted to remind you, you can use equal count and select the data, and it will count how many items there are for you, so you can use that. And then we're ready to do our formula. So, call this class width. And over here, equals, we're going to do range, and then divided by. To do the square root, you type out SQRT, and then you can again double click on this, or you can just start the parenthesis, and then we want to do our 50, which you can of course just type in. Okay, so I'm going to keep that up there for a minute so you can look at it if you need to. And then our number looks like 3.6. We're going to round up to a whole number or use something close. Now, just so we can talk about something else, I'm going to actually have us use the class width of 4 here. That way we can compare it to what happens if we use a different number than up above when they used 5. Okay, so we're going to set up now a frequency distribution. Okay, so that means our table that has our class intervals and then our frequency in 2 columns. Okay, so wherever you have some room here, our excuse me, our intervals are talking about our percent of foreign-born residents. Okay, and then our second one is frequency. It's okay that these overlap. It's just for our own use here. But if that bothers you, go ahead and click on it. And if you go up to the top here, this wrap text will make that auto adjust so it fits. Okay, so if you want it not to hang over into the next one, okay, you can adjust your column width up here, or you can hit wrap text up at the top. And we're going to set up our classes. So we decided we're counting by 4s, so that means included bracket 0, 4, but we're not counting all the way to 4, it's just almost. Then our next one would be bracket 4, 8, parenthesis, all the way down until we get to our maximum, which was 27.2, so we'll just have to go to 28. Okay, Now if you'll notice, we have 1, 2, 3, 4, 5, 6, 7 different classes, whereas up here we had 1, 2, 3, 4, 5, 6. We're splitting it up into smaller chunks, so it makes sense that we'll have more bars in our picture. We'll see how that affects the total display. Okay. Now, in this chart, it gives you a reminder. In order to use the equal frequency function on Excel, you're going to have to set up the upper limit bins to use that function. So just to the side, wherever you want, we're going to set the last number we want Excel to count in this interval. So we don't want it to count 4. Here, all of the values in this table are rounded to 1 decimal place. So the highest number that would work for us is 3.9. And then our class size or width was 4. So I'm just going to add 4. So I said equal, grab the cell, add 4. That way I can drag it down. You're welcome to just type those. Again, that's a laziness, but also efficient way to get those upper limits. Okay. So I will give you a minute to take care of that, and then we'll move on to the frequency section. Okay. Remember, we're using our frequency function Excel to fill this out. If any time on the test you forget what you're doing with Excel, you can always do it by hand. Okay, would it be time consuming to count out each of these? Yes, it would. But can you do it? Also, yes. Okay, sorting these into the correct order would be helpful, and I showed you how to sort those using your data tab last time. Okay, our frequency, let's go ahead and start with it. Equals frequency. It says the data array first, so we're going to go up here and grab our data table, and then comma, the bins array. So if you try to do this and you select this interval like your typed out nice version, it won't let you. It's going to give you an error. So if you forget about the upper limits, it will tell you something's wrong. Okay, then we'll select that. And then remember, there's going to be one at the end that's the spill, the leftover. That just tells you you actually had an exhaustive set of classes here. You covered every number that was possible. There was nothing left out. So it's good news that you have that extra 0. Okay? So now, what we're going to do is go ahead and turn this into a histogram. So we're at the point where we're going to now select the whole table and choose Insert Recommended Chart. So highlight your table. You can do it with the labels or without. It doesn't matter. It's not going to make a difference. Sometimes if you select the labels, they'll import some of that information, which is nice. But if you don't, we'll add it ourselves. Okay? So we're going to go Insert, and then this Recommended Charts button is going to pick the right one for us. It looks like a bar graph because of the gaps. We will fix that. Okay, but this is why, if you'll notice, our intervals, we set up the time to write them nicely, is so that those labels already exist for us. Okay, so we're going to hit OK, and then we're just going to drag this over to the side. Don't do what I just did. Grab the big area, and we'll move it over here so we can adjust the things. So if you click on this plus button here, we can add the axis titles. Okay, our bottom is talking about our percent of foreign-born residents, and you can, we typed it once, highlight it, and paste it in. If you didn't type it earlier, now is the time where you need it, because if you're doing this on a test, I will be grading your, your histogram by those titles as well. So we've got that. And then over here, frequency is great, but also knowing what that frequency is counting is appropriate. So this is talking about how many states fall in each of these intervals. So the label is states. So this first one, 16 states had between 0 and 4% of foreign-born residents, and so on. Okay. Next thing we're going to do is get rid of the gap. So if you double-click on this, you can go over to the right. This will automatically pop up. where you just have to change this gap width to 0. Okay, and the last thing we're going to do is add a nice descriptive title. So that basically just means put the two labels that you have together. So this is the percent of foreign-born residents by state, or for the U.S. And that's it. Okay. There are other ways to make a histogram, but this is my favorite because it looks the closest to a real histogram. Now, you can make this fancier by adding some other things. If you go back into this plus, you can add the data labels. Ours is a discrete value over here in terms of like states is a whole number, so it's not necessary to add those, but sometimes it's helpful. Sometimes it's helpful to do those things. We don't really need it in this case. All right, so what I'm going to have you do now is copy the frequency distribution for the reaction time example up above and see if you can repeat that process. Okay, I have these instructions here to kind of help you, but that's all you're really looking for, is to see if you can do that. Okay, so pause the video and try that for me, please. Alright, I've got this copied, and I went ahead, if you have any issue with the cell reference, which you will if you just copy and paste it directly, we worked on fixing that using the absolute cell reference to lock that in. That is one option you can do, is fix it that way. What I just did is copy and pasted all the things that they referenced, meaning the data itself and those upper limits. That way these were copied down. Worst case scenario, you just copy the numbers. So now, just to walk you through this so you can check, for those of you who struggled, here it is. We're just going to highlight our table. We're going to go Insert, Recommended Charts. First one will do it. Okay. Then we're going to add the axis titles. So this was talking about reaction time, or response time, I should say. And it was in milliseconds, I believe. Don't judge my spelling here. Okay, and then over here, the frequency. This one is true, just the amount of like responders or count. So it's okay to just call it frequency. Frequency here. And I'll just say response time for mouse clicks. Something along those lines. Last thing is we got to get rid of the gaps. Okay. If we double click on the bar, it'll auto pop up, change it to 0, and there it is. Okay. So we've got our histogram based on that. And that's it. Okay, last thing I'm going to talk about is shape. Okay, so going back up here to our two different histograms is talking about what happens if we change the number of bends. Okay, so excuse me, we had this one example that we did by hand, and remember we changed the class width from 5 to 4. So our shape changed a little bit. We're still positively skewed, but it's a little bit more volatile in terms of what the bars are doing. Okay, instead of going down every single time like this one was, it alternated a little bit. So it went down, down, way down, but then it went back up. Not a huge change, so I don't think there's anything wrong with making the change between this and this, but you do want to be careful of having too many bends or not enough bends. So I have this visual here, and this isn't on yours, but I wanted to bring it up. So this is the Goldilocks rule for bins. You know, too few, it's going to hide the trends and oversimplifies. It's not going to show you the patterns that you're looking for. What we're looking for is trying to balance the detail with the clarity. We're seeing the trends, but we're not seeing too much noise or up and down, that volatile action. Like I said, the two examples between a change of 4 and 5 didn't affect it that much. So when it's too many, you're going to notice. It'll be obvious. And when it's too few, the same thing is true. So you may have to adjust your class width to decide that appropriate one, which is where that rule of thumb that we talked about, the range over the square root of n, will help you. Okay. If you have any questions while you're working through the homework, please send me an email, and I'll get back to you when I can.